Okay, so let's get started then. And just let me know if you can't hear or see all that well. It is easier to see. There will be a lot of code during this, so definitely come up into the front section if you really want to see that. If you want to see how we're actually testing our infrastructure, you'll probably need to get a little bit closer. And I'm sorry that everything is inverted. Everything originally was in dark mode recorded. There's a little bit of glare on the display. So inverting was the only way you'd be able to see anything. So it might look a little funny. All right. And so thanks for having me here today. And I hope you're all ready to learn a little bit about Tofu and how you can test with it, or how you can test that it's working. And so I'm Douglas Flagg. I'm a principal cloud engineer at Fidelity Investments here in Durham. And I've worked with various infrastructure as code, or IaC tools, throughout my career, from CloudFormation and Ansible to Terraform and OpenTofu. The team I work on at Fidelity helps pave the path for the IaC tools we encourage the individual Fidelity development teams to use. So we see all kinds of use of IaC from across the business. We also help investigate and drive adoption of any new IaC tools we determine are a good fit for Fidelity. And so today, we're going to be talking about OpenTofu and how you can use it to manage your infrastructure. And so let's get cooking with Tofu. Supposed to be some laughs there. All right, you can see that all right, right? Okay, decently enough. Let's see what we're going to be talking about today. First, we'll do a rough history of IaC and where OpenTofu comes into that. Next, we'll explore some of the advantages Tofu offers over other IaC tools. And then we'll introduce some of the most common Tofu commands and how you can use them. And then we'll return to focus on the really essential aspect of what we're here today, how you can test your IaC works correctly. This is something that kind of comes late for IaC, so let's talk about that. And throughout this entire presentation, we're going to sneak in 4 different examples if we have time to get to them all. That's going to show you how to create infrastructure as code with Tofu and also how to test it. So let's talk about a rough history of IaC. So before there were tools specific for configuring your infrastructure, you might have had procedurally run custom install scripts that teams would develop, and it was to install their specific software. Obviously, these were very fragile. They would require constant updates just to set up their specific systems, and they might even act differently if run multiple times or more than once. Next, what we see emerge is a wide assortment of configuration management tools. These would be your Ansible chefs and puppets, which were created with the primary aim of configuring fleets of servers in a standard and repeatable way. This gave infrastructure deployments far greater consistency because they're written in that tool-specific language, and oftentimes these were even written in declarative languages, which offer additional benefits. Then the cloud came along, and the major cloud service providers opened up their APIs for the world to use. There were now many new imperative ways to use those cloud APIs. You've probably seen Bodo 3. This is one way. They also provided helpful IaC configuration languages over their APIs. This would be, for example, on CloudFormation or on AWS, you have CloudFormation. On Azure, Azure Resource Manager. Can't remember what Google uses, but they have one too. So now we see cloud emerge as a first-class citizen for requiring infrastructure tools that catered specifically to interacting across many cloud providers. You've probably heard of Terraform. Pulumi is another example of this. These cloud-agnostic tools will create infrastructure across your CSPs and SaaS providers through a single language and shared variables. This made these deployments rather repeatable, and you only needed one tool to deploy across them. So let's talk about where OpenTofu comes into the picture. So you may have heard August last year, there was a fork of the Terraform source. This was originally called OpenTF, so you may still see some names of that. In September, the Linux Foundation adopts OpenTF and renames it to OpenTofu. And this gave it much certainty that it had a future. And it has the support and resources it needs to thrive under that organization. In December, there was the first release candidate of that Tofu CLI. And in January of this year, we get Tofu 1.6.0. Today we have at least 1.7 and 1.8 releases available for Tofu as well. I'm pretty sure 1.9 is probably not too far away. So why would you want to use OpenTofu over other alternative IaC tools? So Tofu works out of the box with numerous major and minor CSPs and hundreds of other SaaS providers. It's backwards compatible with Terraform. OpenTofu has made a commitment to continue to remain compatible with Terraform, at least for some time. So that means you can reuse any of your existing Terraform source and knowledge on Tofu. It also includes a native language feature for writing unit and integration tests. This gives you even further assurance that your Tofu configuration or source acts exactly as you intend it to. Because it's a declarative language, that means wiring and precedence between your resources is largely handled by Tofu. Although you can put your finger on the scale and decide to tell it to do other things, it will handle it for you out of the box in most cases. So it determines which order new resources need to be created or torn down. Tofu will also allow you to preview changes by running a plan, which will tell you what Tofu needs to do to create the resources to make that possible. Yet it won't yet create those resources. Now, most providers and resources will apply changes in an idempotent fashion. What does this mean? This means that if I apply the same change more than once, Tofu will recognize that and say, I've already done that, I don't need to take any action, which is useful because you don't want two of the same server if your configuration only says make one. All of these advantages mean real cost savings. With these automations that Tofu provides, you can manage your infrastructure with fewer errors, and there's far few manual steps if you set it up correctly. Now, many IaC tools do offer some of these advantages, but fewer is easy to use or more widely compatible as Tofu with its provider model, inherited from Terraform, obviously. Okay. So, how does Tofu work? Let's talk about some of the basic CLI commands. Terraform users can use the Tofu CLI as a drop-in replacement for the Terraform CLI at this point. And you will still see some references to Terraform in many places in both the Tofu source and state. Now, this is all to maintain compatibility with Terraform, so just note that. Basically, all Tofu IaC follows a very similar pattern when deploying. First, the Tofu directory needs to be initialized with the init CLI command. This will pull down all the dependent providers and modules, and any providers those child modules also require. Next, you can optionally have a plan with the plan CLI command, and this will give you a preview of what Tofu determines is going to be necessary to create the state of the infrastructure to match that, but not yet create anything. Finally, we deploy the changes with the apply CLI command. This can generate a plan on its own or take one as input. It will then match your current infrastructure. It will basically create the resources you need to create the infrastructure that your Tofu state describes. So if it says create 3 servers, at the end of apply, you should have 3 servers if everything went correctly. Now, init only needs to be done once unless you change your providers or the modules. So you don't need to do that in between plan and applies if you're doing multiple plan and applies. And the plan and apply loop is something which you would do constantly when using OpenTofu. So make sure you become familiar with that. First you plan, see what the plan says, then apply it. If it's in a pipeline, you don't worry about this so much, but you may have automation that checks if certain things are happening the way they should, and we'll talk about how you can do that in a little bit. Also, many of the CLI commands offer a JSON output option. Now, this will let the CLI output easy to consume JSON in a standard format that can be consumed by other automation or tools. So if you wanted to check to see if you're deleting a resource when you don't expect that to happen, this is a great place to do that with that JSON output, especially from the plan, and we'll show you how to do that in a second. So let's go into our first example here. Sorry if this restarts. Okay. So in this first example, we're going to keep things as simple as possible. This example uses a local file provider to create a text file and write some content into it, so nothing crazy. With a simple unit test, we're going to verify the name of the file is what we expect it should be. So let's make sure this is running here. Okay. So let's take a look left. We see our main.tf file, and we can also see that there's a required providers block there. So that's how we're going to import the providers we're going to use to create our resource. In this example, we're just creating a local file resource. But this is how on line 3 and 5, it should be moving towards that now. This is how we'll create that provider, or pull in that provider. And so Tofu knows to manually download that, or knows how to download that. Below that, we have a resource block. It's a local resource. And so this will create a local file named goodbye.txt and write the content hello tofu into that file. Its local name in Tofu is hello, so that's that reference there. So let's run tofu init so that we can download the providers and actually run this. And we can see in the .terraform directory for backwards compatibility, we can now see that the provider is now downloaded. And so how do we check to see what this is going to do? With a Tofu plan, we can see exactly what Tofu plans to do to make this possible. And you can see right here it's saying, I will create a local file with the local name hello. I'm going to write the content hello tofu into this file. I'm also going to call the file goodbye.txt. And so that was plan, but no programmatically it's going to do that. Well, we can check that with a test, a tofu test. So we have our test run here. We can name this whatever we want, and we're setting command equals plan. So this means run the test from plan. Don't create any resources, just run the plan and see what it says. We have a variable here where we have our expected file name. We're expecting it to be hello.txt. You might see a potential problem there, but let's just see how this goes. I just pause it for a second and call out this assertion block right here. We have a condition within that assertion block. That condition says the local file, hello, its file name should be our expected file name. And so let's continue and see what happens here. Below that, we also have an error message that we put, and that error message just says our local file resource, whatever value we got, should be this expected value in case it fails. But it's not going to fail, right? Let's run the test and see what happens. It's usually red, but so the file name found obviously was not as expected. It was goodbye.txt when it was supposed to be hello.txt. So let's fix that. I'll just type away. And let's rerun the test. And great, it passed. It's usually, but invert it again. Okay, so we haven't actually created any resources yet because we've just been running plan and test with plan. So let's run tofu apply, and this is going to create another plan, but it's asking us, do we want to apply this? And we say yes, and now it says, I created one resource. And if we look here, we can see that local file resource, the hello tofu, written to it. And that's great, but let's complete the life cycle here. So if we run tofu destroy, this will delete that file. And you can see it saying right here, I will delete this file. And you can see the file is now gone. And that concludes our first example. All right. So plan alone doesn't give us great assurance that what we have here is actually working. So let's talk about some of the other ways that you can test your Tofu IaC. There's several other Tofu CLI commands that can help you in your process to developing good infrastructure. The first is the Tofu console command. This command is going to spawn a REPL, which will let you quickly evaluate whether a line of tofu is syntactically valid, as well as basic logical evaluations like conditional statements. You can check in this. Next is validate. This will give you quick feedback that all your .tf files, those are your tofu source files, are syntactically valid. You can use this command on its own, but plan will also use this as well. So if you're running plan, there's not really a need to run validate. The show CLI command can optionally be used with the JSON flag. to convert some binary plan file into a general purpose machine readable format. And this, like I've been hinting at earlier, is a good way to check to see what the plan is going to apply and check it against something you don't expect to happen, like resources being deleted or new resources being created, if you know that beforehand. Now, all Tofu config has the ability to generate output passed from the source, and you can do this with the output command. This output can be consumed by other Tofu modules, so you can have hierarchies of modules calling into each other. We will return back to talk about a little bit more what modules are in a minute, but just know that output can be used by other modules to consume other module output. It can also be used by other automation or just to validate some fact about the infrastructure, whether something's true or not. And finally, our test command. We used this in the previous example, and what that tofu test command does is it runs all the tests it finds in our tft-test.htcl file. So any of those test files in that directory, it will run the tests for those. And that has access to all the local variables in our tofu config. Yeah, and there's lots you can do in those validations, like checking that the name of a file is as you expect it to be, which is what we just did in that example, or checking that some server is available and returning the status codes that you expect it to. Lots of things are now possible to test through the language. Let's go into our second example. And so in this example, we're going to use the AWS Tofu provider to create an S3 bucket with encryption configured. So we're going to be creating real resources here. We're also going to use a pre-existing KMS key. We'll also demonstrate how the test feature in Tofu can be used to implement both unit and integration tests and describe what the difference is, or what I think the difference is. These tests will not only validate that the plan predicts something should happen, but will validate in fact that real infrastructure was created as you expected it to be. Okay. So let's go back to the demo. Might need to seek ahead a little bit here. So we can see right here to pull down our providers or describe which providers we need. We have a new provider. We're using the AWS provider in this case. So this is going to let us create real resources in AWS. That's what this provider does. Restart it. Below that, we have a variable block called bucket name of type string. So this is how you provide input to your Tofu configuration. We also have a default value, so we don't have to provide a value. This will be used if nothing's provided. Below that, we have our AWS S3 bucket resource. So this is going to tell Tofu to create an AWS S3 bucket. It's going to use the variable name from our bucket name we had before, and then it's going to apply some tags to that. Let me slow it down a little bit. So it's going to use the variable to create that bucket. It's going to give it that name that we provided from the variable, plus the tags. We have a data lookup block below. This just lets us look up some details on a KMS key. Data blocks are some way to get information about your environment or about the environment around you, or to make some kind of HTTP request or something like that. We'll show those in a bit. But it's not going to create any resource. That's the difference between these two blocks. So we're looking up some details on our KMS key here. Specifically, we actually want to get details on its ARN. And this is that pre-created KMS key. And we have our last resource here, and this is the server encryption configuration on our bucket. You can see we have a reference back to our bucket resource. We need to get its ID so we can apply the encryption to the bucket. We have the configuration for how you apply that encryption rule. We need to provide the KMS key that we want to encrypt it with. And so this is the way you reference that. Tofu. So simple enough there. Like always, let's run tofu init so that we have the provider available. Yep. And let's talk about some of the tests here. So we didn't talk about it in the previous example, so I'm going to talk about it here real quick. I'm roughly describing these as unit tests, and that's because when we run with command equals plan, no real resources are created or torn down. What's going to happen is it's just going to run the plan. It's going to take the output from the plan, and that's the only input it's going to use to test for your in the context of the tofu test. Integration tests are what we're going to call when we're actually applying it, and we will get into those in that next file. Let me just restart this. Okay. So we also have a bucket name variable that we've added into our test, and because this collides with the variable we have in our main TF, it's going to use this value for the test. So just be aware that that's how you provide variables from your tests. We have an assertion on the condition to check that the bucket is the bucket name that we expect, and then an error message below that. In the second assertion, we're checking that the bucket's tags are the tags that we expected, so those two tags we had above. So let's run our tofu test here. And we're going to use the filter in this example, so this will only run the tests within that particular file that we're filtering on, and that's the unit tf-test.htcl. So only our unit tests are going to be run here. And this should just take a minute. Forward, but you can see that that was successful. That's good. Let's talk about our integration tests. We have a new variable block in a new place, so this is now global to all of our run blocks because we have multiple run blocks in this example. And we also have command equals apply. And so this tells Tofu create real resources to test against in this example. This is the default behavior, so if it wasn't provided, it would still do this. Plan is what you have to specify if you just want to run from plan. We have an assertion condition that says, is the bucket name we expect? If you remember from the previous example, this is the exact same thing we're testing. We're just showing you here that you can test this from both plan and apply. Some things are known as early as plan, but not everything is. And we have our second assertion down here that's checking that a particular encryption rule is configured appropriately. And that's just a setup for that right there. We use JSON encode to check that that condition is true. Basically, we're checking that the encryption configuration is applied exactly as we expect. And then finally, we're checking that the encryption configuration is applied to the bucket. That's what this last one is doing. And so now is the time where we can run the integration test. And these should actually take longer to run than the unit test. I don't know if my computer was going slow when this was happening, but these actually kind of go quickly. So this is spinning up real resources. This is creating an AWS S3 bucket. It's applying encryption to it. And then it's running the tests. Then it's destroying everything. And we can see that the 3 tests have passed. Oh, that's great and all. But we haven't actually created any non-transient resources in this example. So let's run a tofu plan. But in this case, we're going to run a plan with an output file. And this output file is going to be where we're going to store our plan information. This is going to be a binary file, so we can't read it directly, but we'll show you how to take a look at it. It's still going to print out details on what it plans to do. And so you can see right here, it's planning to create that encryption configuration. And note right here, bucket known after apply, ID known after apply. This is a really strong hint that that is something that you must test from command equals apply, because it's not known at the time of plan. So that's a case where you would have to test that from command equals plan. And right here, we're going to run tofu show with that JSON output. And so this is a way you can check that your plan is doing something it should or should not be doing. And this is something you would probably want to do in a pipeline to ensure that unexpected things are not happening. So we can take a look at that plan too. This is just using JQ to cut it up and see what the contents look like. And that's fine and all. Let's apply this. And note that we're running tofu apply and just providing the plan file. This won't prompt you, and this will just automatically create that those resources there. And so you can see it's created 2 resources. Also note that we have a tofu state or a terraform.tf state file here now. That'll be important later. Just note that it is a local file right now. Yeah. And let's go on to our next example. Or back to the slides. Okay. So let's return to talk about some really important Tofu concepts that we talked about a little bit, but didn't really explain exactly what they do. So to keep it super simple, let's think of Tofu state as the details that let the Tofu CLI map existing resources in the cloud to resource blocks in your Tofu state. Now without state, your Tofu configuration has no idea if you've already created that S3 bucket or not. So this is what keeps that mapping, so it knows not to create a new one. Or it knows to delete an existing one, if that should happen. And now by default, all the Tofu state files are going to be stored in .tf state files. And for backwards compatibility, they're going to be stored in terraform.tf state files for Terraform compatibility. And these files are stored locally if you don't have a backend configured. We'll show how that works in a second if you do want to configure a remote backend. Now, Tofu providers are the glue that connects and maps the Cloud CRUD API operations to the binaries in your Tofu CLI that are invoked against those cloud resources for you. And these are those binaries that are automatically downloaded when we run Tofu init. And so what are those CRUD APIs? That's your create, read, update, delete. So these are the binaries that know how to read from your AWS resources or Azure resources and check to see what's already there, so it knows what to update or knows what to delete. That's where all that logic is. There are numerous providers for all the major CSPs. You'll see them for AWS and Azure, and you'll see many, many, many more for the SaaS providers like Datadog, Splunk, New Relic. Everything else basically has a provider for it. Anything with an API can have a provider written for it. Tofu modules, that we've kind of hinted at, it's pretty loose what they can be. Any directory that contains .tf source files can be a module, depending on how you use it. Often when we have modules that we want to reuse because they do something helpful, we can add some variables to them to make them, to give them some reusability. We can also put them into module registries so that others can discover and use those modules. Now, the Tofu provider registry is that map that by default all of the Tofu provider binaries are discovered through. So when you're running Tofu init, it is connecting to that provider registry and discovering where those providers for that particular version of your operating system is and downloading them. Now, the registry only provides download links for the provider binaries and some mechanism for resolving which version, because you can give all sorts of version constraints saying, like, I want to float the patch version. It will be able to negotiate those kind of things. Important to note that Tofu shares the provider sources from the Terraform providers. It even shares the Tofu or the Terraform provider binaries as well. It's just using a new registry. It uses a separate one than HashiCorp's Terraform registry. And important to note that those, at least most of them, are still registered under MPL v2 outside of the Terraform core. And the module registry, similar to the provider registry, just a place to discover modules. This works very similar to the provider registry. And so let's talk about our last two examples. I'll try to go through them quickly because I see I only have 16 minutes. Yeah. And these ones we'll get into a little bit more advanced tests. Okay. So this example creates an AWS API gateway, and it's just going to proxy some JSON hosted elsewhere. It's also going to show you how to use an S3 state backend to store your Tofu state files remotely. We're also going to show you how to validate that a service is up and running through two different methods after being deployed by Tofu. Okay. So let's take a look at our provider TF to look at that backend configuration. So how are we going to store our state remotely in S3? So you can see at the top here we have a bucket that we've configured. This is that bucket default that we had before. So this was the bucket we actually created. It's going to store the state file in this bucket at this location where we have the key under states, state backend example in that particular region. Below that, we also have our usual provider configuration. We're using the AWS provider. We're also using the HTTP provider. that HTTP provider is going to let us make HTTP requests at will through data blocks, which we're going to need in a minute. But the first thing we want to do is actually see what the state backend looks like. How does it operate? It's hard to see it without actually creating any resources, so we're just going to run tofu apply and create a resource, or create the resources in this example. This is going to create an API gateway. Don't worry too much about those details. We just want to see that it's creating this state. And you can see it saying it's creating this stuff. That's great. That's what we expected. And this will just take a second while that's creating. And you can see that it's done. Note that we don't have a Terraform or any .tf state file here because it's stored in that remote backend. It's stored in our S3 bucket we created in the previous example. And you can see me searching for it here. So that's what it looked like in the previous example, was that file. Right, it's missing. And we can use the tofu state pull to just pull down and take a look at that state file. You wouldn't normally do this. It just knows about the state file. I just want to show you that you can access it if you absolutely need to from the CLI. So let's just delete these resources because we don't actually need them. This was just to show you how the backend works. Obviously, you don't want to lose your state because if you do, then you don't have that mapping anymore to know where your resources are. Okay, so let's talk a little bit about the API.tf, so the configuration we have here. So above all this is the details for creating the API gateway. I won't go into all the goriness of that. Don't worry about it. Just know that it is creating an API gateway for us here, and it's just proxying some static JSON. We have a locals block here that's just a local variable we're going to create for our service URL. This is coming from that API gateway. We know at the IP's endpoint that we have that static JSON there. So we have a check block here. This check block within it has a data block. It's using our HTTP provider, and we're going to call this HTTP data block our IP service. It's going to accept a URL using that service URL. It will make a request to our API gateway to get back some data from there. Doesn't matter what data. The only thing we're going to check with it in our assertion block is that the status code that it gets back is 200. If it's not 200, something went wrong. And we also have an error message that will print out if it doesn't go right. Super important to note here that the way that check blocks work, because you'll notice that this is outside of our test, this is in our actual tofu config, this is only going to print a warning. So it's going to apply all the resources, and then if it doesn't work, it's going to print a warning. So you got to be looking for this. That's one of the big drawbacks of using a check block. We're also going to output the service URL here. That'll become important in a second. It's actually going to be helpful for when we're testing this. So what if I want to test this in an actual tofu test instead of just testing from after I've deployed my infrastructure? I want to know beforehand if this works. So the way you do this is a little bit roundabout, so you might have to pay close attention if you really want to know how this one works. You need to use a test helper in this case. And so, I went back. Go back. Seek a little bit. Right. And so you need to use a test helper here. And let's take a look at what that test helper does and how it can help us actually test that this module is working correctly. And so you can see right here we have a reference to our main module. And what's our main module here? That's just our API.tf and our provider TF. And that's that main source that we've spun up that's spinning up the API gateway. Let's play. And so you'll notice it depends on within our data block here, this data block that we're using for the test. This depends on the main module. We'll tell it this tofu block to wait until the main module is completed spinning up so it can get that service URL and use that service URL to make a request once the infrastructure is spun up so it can check to see if everything's good. You got to do this if you want to set up an API gateway. This is one way you can test it. You don't have to do it if you're setting up an API gateway. You don't have to have tests, but it's nice to. We can at least be a little more certain. And you'll notice here we have our data HTTP block. Again, like we were doing in the check block, we're just checking that it's a 200. And so let's run the Tofu test and see what happens. And so even in this Tofu test, that check block is going to execute as well. We won't really see it because it's not going to fail. It doesn't say anything if it doesn't fail. It actually does print a bunch of stuff out, but we're going to ignore it because it's not really important. We want to actually test our Tofu here with those pre-written tests. And you can see it said it passed. And so we now can be more certain that this API works as expected. So let's jump into our last example. All right. So this example provides a simplified model for a Tofu module that is designed to be reused by other Tofu source configurations. It does require one pre-existing resource reference and a reference to that resource. We're going to demonstrate how you can validate module input, test that the validation works correctly, and finally how to use the Tofu module helper to create dependencies prior to running your integration tests. Okay. So let's take a look at our sns.tf where we've defined our Tofu source configuration. In the background, we'll run tofu init too. So we have a variable up here that's the SNS topic that we expect should already exist before we do anything for this module. So this module cannot work on its own. We're also accepting a subscriber email, or really requiring one because there's no default set. And we have a new block here within this variable, a validation block. This validation block is going to check that the subscriber email you provide ends in a particular domain that we expect it to. If it doesn't, this will error, and this will error quite early on. This will probably error even before plan. And an error message that comes in. We also have a data lookup block to get some information on the SNS topic that was passed in, so we can get its ARN basically, like the previous example. And then we have the only resource that this module actually creates, and that's the topic subscription. So it's just going to subscribe to the topic that you provided. So nothing that exciting happening here, just showing you that we can test this. So we can't just test this straight off. We need to create that topic prior to testing it. And so the way we're going to get away with that is we're going to run a helper module. And we have this stored under the prereqs, or at least it's in a prereqs.tf under setup under our tests. And we'll show you how we call this in a second, but just note that there's some boilerplate in here for the AWS provider it needs. Set some default tags, don't worry about that. And it accepts an SNS topic name that it's going to create the topic for. Below that, we have that SNS topic. We are going to create this topic as part of this just prior to running the tests. This won't happen when you create the actual infrastructure. It only takes place when you're running the tests, so that you can test that that's all working. Let's take a look at what the test looks like. We have some variables for the topic name we expect everything to be, the subscriber email, and then we have a call to our test helper. And so this is going to first call that module to make sure that we've set up all those prereqs. Basically, we've deployed the SNS topic. We're running from command equals apply, so we're creating real resources. We expect the protocol to be email. We check that the protocol is actually email. And we're going to check that the user that was subscribed is the correct user, so making sure everything gets passed through. And then we have a negative test here. So we have a test here that's going to check that the subscription that we provided, or well, the subscriber email that we provided will fail validation if you give a domain or something that doesn't pass that validation. And because we're testing the validation, we can actually run this from command equals plan because that validation happens during plan. We don't need to actually spin up real resources for this example. So we provide a subscriber email that's outside of the bounds of that domain. And then just below that, we show you how to expect failures. And then we'll run this test. And this is the last example and the last test of the last example. This should just take a second. Let's see if I can skip ahead. It actually takes a while. All right, and we can see that that passed. And So thank you so much for coming and learning more about using OpenTofu and how you can test with it. And I hope you enjoyed learning how to cook with tofu. Thanks.